Oxidation number. Oxidation number of an atom is equal to the charge that would be present on the atom if the compound were composed of ions. Note that it doesn't matter whether the compound actually contains ions. The oxidation number is the charge an atom would have if the compound were ionic. The concept of oxidation number is nothing more than a bookkeeping system used to keep track of electrons in chemical reactions. This system is based on a series of rules. Rules for assigning oxidation number. The oxidation number of a free element is 0. Examples: O2, O3, H2, N2, P4, S8, Al, Fe, etc. The oxidation number of hydrogen is +1 when it is combined with a nonmetal. Hydrogen is therefore in the +1 oxidation state in CH4, NH3, H2O, and HCl. The oxidation number of hydrogen is -1 when it is combined with a metal. Hydrogen is therefore in the -1 oxidation state in LiH, NaH, CaH2 and LiLH4. The oxidation number of group 1 elements alkali metals is always +1 in their compounds. The oxidation number of group 2 elements alkaline earth metals in their compounds is always +2. The oxidation number of oxygen in its compounds is -2 except in peroxides where oxygen is in the -1 oxidation state and superoxides where oxygen is in the -1/2 oxidation state. In combination with fluorine, oxygen is in the +2 oxidation state. The oxidation number of halogens in their binary compounds is -1. The sum of oxidation numbers of all the atoms in a neutral compound is 0. The sum of oxidation numbers of all the atoms in an ion is equal to the charge on the ion. The most electronegative element in a compound has a negative oxidation number. How to find out oxidation numbers? First we will find out the oxidation number of nitrogen in NO2 and the oxidation number of carbon in CO2 with detailed explanation, then we will follow the rule for others. NO2 is a neutral compound, so all the oxidation numbers of elements add up to 0. To determine the oxidation number of the element nitrogen in this compound, we multiply the number of nitrogen atoms by X, then multiply the number of oxygen atoms by the oxidation number of oxygen. Then add up all the oxidation numbers to 0. NO2. 1x plus 2 multiplied by -2 equals 0. 1x or x1 and the same thing. When we multiply +2 and -2 we get -4. X minus 4 equals 0. We add 4 to both sides of the equation to get rid of -4 on the left-hand side of the equation. X minus 4 plus 4 equals 0 plus 4. -4 and +4 cancel each other. So X equals 4. CO2 is a neutral compound, so all the oxidation numbers of elements add up to 0. To determine the oxidation number of the element carbon in this compound, multiply the number of carbon atoms by X as there is only one carbon atom, so multiply 1 by X, then multiply the number of oxygen atoms in CO2 by the oxidation number of oxygen. Then add up all the oxidation numbers to 0. CO2. X plus 2 multiplied by -2 equals 0. X minus 4 equals 0. X minus 4 plus 4 equals 0 plus 4. -4 and +4 cancel each other. So X equals 4. Now we are going to find out the oxidation number of underlined elements in these compounds. KMnO4. Underlined element Mn. Plus 1 plus X plus 4 multiplied by -2 equals 0. 1 plus X minus 8 equals 0. -7 plus X equals 0. X equals +7. FeO. Underlined element Fe. X plus 1 multiplied by -2 equals 0. X minus 2 equals 0. X equals +2. BaO2. Underlined element O. We know that group 2 elements always have +2 oxidation number. 1 multiplied by 2 plus 2x equals 0. 2 plus 2x equals 0. 2x equals -2. X equals -1. H2C2O4. Underlined element C. 2 multiplied by +1 plus 2x plus 4 multiplied by -2 equals 0. 2 plus 2x minus 8 equals 0. 2 plus 2x minus 8 equals 0. 2x minus 6 equals 0. 2x equals 6. X equals 6 divided by 2. X equals +3. H2O2. Underlined element O. 2 multiplied by +1 plus 2x equals 0. 2 plus 2x equals 0. 2x equals -2. X equals -2 divided by 2. X equals -1. ZnO. Underlined element Zn. X plus 1 multiplied by -2 equals 0. X minus 2 equals 0. X equals +2. OF2. Underlined element O. Fluorine is more electronegative than oxygen, so fluorine must be in negative oxidation state. X plus 2 multiplied by minus 1 equals 0. X minus 2 equals 0. X equals plus 2. N2O. Underlined element N. 2x plus 1 multiplied by minus 2 equals 0. 2x minus 2 equals 0. 2x equals plus 2. X equals plus 1. FECL2. Underlined element FE. X plus 2 multiplied by minus 1 equals 0. X minus 2 equals 0. X equals plus 2. Now we are going to find out the oxidation number of elements in ions. We know that all the oxidation numbers of atoms in an ion add up to the charge on the ion. So let's start. S4O6-2. Underlined element S. 4x plus 6 multiplied by minus 2 equals minus 2. 4x minus 12 equals minus 2. 4x equals minus 2 plus 12. 4x equals 10. X equals 10 divided by 4. X equals plus 2.5. SO4-2. Underlined element S. X plus 4 multiplied by minus 2 equals minus 2. X minus 8 equals minus 2. X equals minus 2 plus 8. X equals plus 6. S2O3-2. Underlined element S. 2x plus 3 multiplied by minus 2 equals minus 2. 2x minus 6 equals minus 2. 2x equals minus 2 plus 6. 2x equals 4. X equals plus 2. MnO4-. Underlined element Mn. X plus 4 multiplied by minus 2 equals minus 1. X minus 8 equals minus 1. X equals minus 1 plus 8. X equals plus 7. Cr2O7-2. Underlined element Cr. 2x plus 7 multiplied by minus 2 equals minus 2. 2x minus 14 equals minus 2. 2x equals minus 2 plus 14. 2x equals 12. X equals 12 divided by 2. X equals plus 6. NO3-. Underlined element N. X plus 3 multiplied by minus 2 equals minus 1. X minus 6 equals minus 1. X equals minus 1 plus 6. X equals plus 5. I3-. Underlined element I. 3x equals minus 1. X equals minus 1/3 or minus 1/3. Thank you for watching. Subscribe for more videos.